Today we are going to look at the concept of gradient and equations of straight lines, and we shall do the part 1 of this concept, and in our subsequent video we will continue with the same aspect. So first of all, we need to ask ourselves, what is gradient? Ideally, gradient we normally say is a measure of steepness. And this is what most people would want to call slope. It's a measure of steepness, or you can say it is a slope. And to illustrate this concept, we can take a good example of a technician who wants to do some remedies top of a roof that is 3 meters high, and he can climb that roof using a ladder. So we can have our roof here, which is 3 meters high. That is our roof. And then we can have our ground level. So we can say that this technician can use a ladder to climb to the top of the roof. We can assume that the distance from the foot of this roof to the wall, let's say, is 2 meters. That is one ladder. You can still climb the top of the roof using another ladder. You can have another ladder here, which we can say the distance now from the foot of the second ladder to the wall is, let's say, 2.5 meters. That way. So we are going to illustrate the aspect of gradient using this good example. So let us assume now that he uses the first ladder. Let's call it ladder C, ladder AB. We have a ladder AB there. So the ratio which now will yield our gradient is given by the vertical distance. You divide by the horizontal distance. So for the first ladder AB, we are going to have this aspect. The ratio being the vertical distance is constant because he's climbing a wall that is 3 meters. So we shall have our 3 meters, and the horizontal distance is now the distance from point A to the wall, which is 2 meters. So in this case, our ratio which gives us the gradient is 1.5. And then if he uses radar CB to climb up the same roof, we shall have our ratio as 3, which is the vertical height, and then the distance from point C to the wall, which is in this case 2.5 meters. So if you do this, you'll get the same thing as saying 3, you divide by 2.5, which is the same thing as saying 3, you divide by, you convert this mixed fraction into an improper fraction, which is 2 by 2, you get 4, 4 plus 1, you get 5. So it's 5 over 2, which is the same thing as saying 3, you change the sign into multiplication, and then you take the reciprocal of 5 over 2, which is 2 over 5. So you get 6 over 5. And when you do this division, you get 1.2. So from this illustration, it is very clear that ladder AB will give a steeper slope than radar CB, and that is evidenced by the gradients. The gradient AB is 1.5, the gradient 1.2 of CB is 1.2. So what can we deduce from that illustration? And it is very clear from what we can see from this illustration. It appears that the steeper the slope, the higher the gradient. The steeper the slope, the higher the gradient. The higher the gradient. So when we speak of the concept of gradient, that is basically what we refer to as it is the ratio of the vertical distance over the horizontal distance. Having seen what constitutes a gradient, we are now going to consider examples of aspects that crops out of this very interesting topic of gradient. For example, in our case here, we are told to find the equation of a line through the points A, which has coordinates 1, 3, and point B with a coordinate 2, 8. So the keyword here is to get the equation. There is no way you are going to get this equation before you get the gradient of this line AB, which passes through point 1, 3 and point 2, 8. So as we have seen, that gradient, which we can initialize as G, is given by change in vertical distance over change in horizontal distance. But when we come to consider cases of a Cartesian plane, you know a Cartesian plane, how it looks. We have the y-axis there and the x-axis. We are going to have coordinates which are going to be in the form of x, y. That's how coordinates are written. So in this case, we need to have another version of expressing gradient, which is the same thing as change in vertical distance over change in horizontal distance. But in our case, for a Cartesian plane, we normally say that gradient is given by the change in y coordinate over change in x coordinate over change in x coordinate. This is basically written as gradient is given by change. We normally use that symbol for change. So change in y over change in x. So in this case, we have a very interesting point here, that we have a line that passes through point A, 1, 3, at point B, 2, 8. So that means our point A here is 1, has coordinate 1, 3, and our point B has coordinate 2, 8. So if we need to consider the change in y, remember this is what represents the x, this is y, this is x, this is y. Remember we said that coordinates are expressed in form xy. So 1 here is a representation of x, 3 a representation of y, 2 a representation of x, 8 a representation of y. So if we need to consider a change in y, we're basically going to take one point, say B, whose y is 8. So you're going to say gradient here is going to be given by 8, which is the y coordinate for point B. So we continue. So we will take the y coordinate of point B, h, minus the y coordinate of point A, which is 3, 8 minus 3. Then changing x coordinate will be the x coordinate of point B, which is 2, minus the x coordinate of point A, which is 1. So the gradient is 8 minus 3, which is 5, over 2 minus 1, which is 1. So that means the gradient of line AB is 5. But in our question, we had to find the equation of a line that passes through point A and B. So what do we do now? So we'll consider one of the given points, either point A or point B. So we can say that this line passes through point A, 1, 3, and another point, x, y. We consider these 2 points. So we can say that the gradient of this line will be 5. So that means gradient is given by, we have already said changing y over changing x. So this means y minus 3, this is y minus 3 over x minus 1 should give you a 5. And this is now the expression that is going to give us an equation for that line AB. So we simplify this, and this is over 1, so we shall have y minus 3, this is cross multiplication, y minus 3 times 1 is equals to 5 times x minus 1, that way. So you're going to have y minus 3 equals to 5x, 5 times x, 5x minus 5. So we can write this equation in the form, we remain with y on this side, we take minus 3 to the other side. So we shall have y equals to 5x minus 5. When we take minus 3 to the other side, it becomes plus 3. So our equation will be y is equals to 5x minus 5 plus 3 will give you a minus 2. So that is the equation of that line, which is y is equals to 5x minus 2.